Hello, it's What the Doodle here, and in today's session, I wanted to go over an old article, and this is the article. It's called Taco Bell Programming, and it was written in 2010 by Ted, I think it's Dziuba, so apologies, I don't know how his surname is pronounced, and this had quite a big impact on me because it was around this time that I was investigating and looking into Linux and slowly making my migration away from Windows. And although this is an article from 2010, a lot of the things in here still resonates to this day. So let's get into it. Every time on the menu at Taco Bell, every item on the menu at Taco Bell is just a different configuration of roughly 8 ingredients. With this simple periodic table of meat and produce, the company pulled down $1.9 billion last year. So obviously, a lot of money essentially, but who knows what Taco Bell is obviously very famous. It's a well-known brand, and I don't know how much it's making in 2024, but it's making a lot of money essentially. So the concept here is the idea that the actual menu is very simplistic, but regardless of the fact that it's very simplistic, the actual outcomes in terms of financial success, it's it's a very powerful solution just by using simple combination. That's sort of a very interesting opening. I guess it's like an analogy, so it plays quite well to kind of set the tone. So carrying forward, the more I write code and design systems, the more I understand that many times you can achieve the desired functionality simply with clever reconfigurations of the basic Unix toolset. After all, functionality is an asset, but code is a liability. And I remember this because this particular line sort of stayed with me for for a long time, and even to this day. And initially, when I read that, I was a bit, what does he mean by that? But over the course of my career, I have actually come back to this, circled back to this specific quote, and I do absolutely agree because when you write software, when you write code, there is a potential for a lot of bugs, a lot of issues around that code, and you almost have to see the code itself as liability, because of all of the potential issues that it could have. So it's the functionality that is the actual real asset, which is essentially the whole idea is about customer orientated. So you have to look at it, or customer slash user orientated. That's the view it should be, because ultimately you have to ask yourself, well, why are we programming? Why are we creating these programs? And why are we doing this software development? Who's it actually for? Who does it benefit? And really, it's a means to an end. We are programming in order to serve customers and end users, and that is done by in terms of the actual functionality and the features that a particular solution delivers. And so it isn't. We need to, as engineers, we need to kind of step back a little bit and not be so myopic, sorry, and focusing and put too much emphasis and focuses on the code itself. We need to get away from that. Sometimes there is a bit. Sometimes that can happen where we focus way too much on the actual code and then actually forget the outcome, the actual solution, what it's supposed to do. And this is why sometimes we can get into areas of over abstraction and over engineering. So anyway, let's carry on. This is the opposite of a trend of nonsense called DevOps. Well, perhaps that might be a little bit harsh. I wouldn't go as far as that. I think that the DevOps is a domain that is needed, I think, in modern sort of cloud infrastructure and the way that the organizations have kind of evolved. I do think it's needed. Perhaps in 2010 this was more emerging, and so it was a lot of question marks around it, I guess. But I think it's widely accepted. DevOps is widely accepted now, where system administrators start writing unit tests and other things to help the developers warm up to them. I know this is just tongue in cheek, so he's not. It's just being it's a little bit sort of tongue in cheek here. Taco Bell programming is about developers knowing enough about ops and Unix in general so that they don't overthink things and arrive at simple, scalable solutions. So yes, that is correct, and this is what I was mentioning earlier about not over engineering, and also about simple solutions. Kind of the whole movement around using boring tools and boring stacks in order to deliver the solutions, and not to over abstract and not to over engineer, over complicate things. I don't know if that sort of extends to DevOps. I'm not too 100. I don't 100% agree with that part of it there, but I do understand what he's saying about where he's saying that Taco Bell programming is about developers knowing enough about ops, and I think that is important. I think sometimes it's referred to as full stack engineer. The idea that that you don't segregate all of these different responsibilities. Well, certainly not to so that there is enough, and I think I think the knowing enough is important here, because obviously all of these various different domains or different parts of the stack, if you like, so front end, back end, database, security, infrastructure, all of the and networking, and all of these different domains, they have their specialization, and we absolutely do need specialists in those areas. I think the danger is if you have individuals who are completely specialized into one particular domain without having any foresight or any kind of observability of the other domains, that's when it becomes problematic. And I think that's the important part here, is that developers knowing enough. So when individuals talk about, or when the term full stack engineer is floated about, of course, it's a very nebulous term, and it can mean a lot of different things for lots of different companies, because it is not well defined. And one company's definition of a full stack engineer will be wholly different to another company's definition of a full stack engineer, because these things aren't that well defined, and they mean, as I said earlier, they mean different things to different companies. But the only thing that I do agree from that kind of full stack, because the only thing I do agree from that sort of full stack engineer is the idea that engineers are generalists enough that they have a general idea of the various different domains, but they don't have to be specialists in them. So enough to be sort of dangerous, but not to be an expert in that area, because nobody can be an expert in every area. That is a simple brute reality. But that doesn't stop us from having an understanding. And the reason is because when you have an understanding, you have a holistic approach to solving things. So you don't have this fragmented, isolated worldview where you develop something in isolation without understanding the potential impact of that solution. But obviously you wouldn't be able to understand that impact if you don't have that generalized, overview and oversight of those other domains anyway. So carrying on. And Unix in general, so that you don't you don't overthink things and arrive at simple scalable solutions. Yeah, and that ties together, is that if you have that overview of the various different, so you generalize over the various different domains, you can have that sort of joined up thinking essentially. So here's a concrete example. Suppose you have millions of web pages that you want to download and save to disk for later processing. How do you do that? The cool kids answer is to write a distributed crawler enclosure and run it on EC2, handing out jobs with a message queue like SQS or 0MQ. So, of course, this is sort of sarcastic humor, where essentially he's just showing an overblow. It's sort of, I don't know anybody who writes crawlers in Clojure, but you absolutely could. And I do actually like Clojure. I think Clojure is a wonderful language. It is obviously of the Lisp heritage. And I think actually, ironically, sort of for data munging and data related kind of things, Clojure is actually not too bad, I think. It is niche, of course, and so there is that to be aware, but I do think it's worth absolutely worth learning, just even from an just personal improvement and whatnot. And anyway, so obviously this whole thing is completely sarcasm and essentially just trying to say how you would over engineer something, and then obviously moves on. The Taco Bell answer: xargs and wget. In the rare case that you saturate the network connection, add some split and rsync, a distributed crawler is really only like 10 lines of shell script. So obviously, yes, sort of in this sort of not contrived, but in this example, yes, at that scale, yes, you absolutely should initially you know, do the simplest thing that works. That's the first way to do it, using existing tools that you have to hand. And this would be the right approach. So obviously things like xargs, I believe, if I remember correctly, it's a way of sort of running things in parallel. So you take the commands and you sort of split it up. And wget is sort of a specialized. I don't know if it's a specialized version of curl, but it's specifically to pull down binaries. So you give it a URL, and then you give it a URL, and then it pulls that data down using that particular endpoint that you've passed to it. So things like split, of course, is that you can take a file and split it into different chunks. And rsync is when you have two different sets of files across different folders, and you want to synchronize them, kind of used in sort of incremental backups and all sorts of other areas. So moving on, once you have these millions of pages or even tens of millions, how do you process them? Surely Hadoop MapReduce is necessary. After all, that's what Google uses to parse the web, right? Well, yeah, I mean, I think that was MapReduce was the big hotness and part of the whole big data back in 2010. But of course, that's now sort of fallen by the way, and a lot of other newer things have taken its place. But I believe there probably are some MapReduce not code bases solutions out there still probably carrying on. And then it says, poof, F that noise, and then he says find the call directory, type F, print out each of those files, and then pipe it into xargs, and then obviously run it across 32 concurrent processes, and then the actual binary that you want to execute over that. So 32 concurrent parallel passing processes and 0 bullshit to manage, requirements satisfied. Every time you write code or introduce third-party services, you are introducing the possibility of failure into your system. I have far more faith in xargs than I do in Hadoop. Hell, I trust xargs more than I trust myself to write a simple multi-threaded processor. I trust syslog to handle asynchronous messages recording far more than I trust myself, trust a message queue service. So yes and no. Of course, it depends. The idea about multi-threaded processing, all this kind of stuff. Systems programming, of course, if you are doing that in things like C and C++, which generally would be for this kind of stuff. This is prior to sort of Rust gaining kind of the limelight and popularity. Yes, it absolutely is. Those kind of things are difficult. And I think this is where this is not to shill Rust a little bit. Essentially, a lot of the actual language itself and the semantics around that, the design of that, was to allow for like really building safe multi-threaded processing to save across things like data races, and not to allow that to happen because you encode a lot of those things in the you leverage the type system, essentially the language and the type system, so that you can have compiler guarantees. Of course, that's not to say that you can't have you can't have bugs in that, but it makes it a damn sight easier than if you were doing it in languages such as C and C++ that didn't have those language features and language designs and type systems to lean upon in order to handle that. So things of I get that, but I do understand the sentiment. If you were to write a multi-threaded program or multi-threaded application in languages like C and C++ and so forth, then yeah, I would have the same kind of nervousness. And but it is true, obviously, of course, things like xarg and these other binary utilities and these tools are battle tested. They've been around for years, if not decades, and are well trusted in terms of their reliability. So yes, it makes sense, of course, whenever you can lean towards existing things that are there, rather than to try and sort of roll your own. Essentially, that there is that acronym NIH, which is not invented here syndrome. Of course, in some cases you should do that. But most of the times you should try and avoid it where possible. So, and then he goes, Taco Bell programming is one of those steps on the path to Unix Zen. This is the path that I am personally just beginning, but it's already starting to pay dividends. To really get into it, you need to throw away a lot of your ideas about systems, how systems are designed. I made most of a SOAP server using static files and Apache's mod rewrite. I could have done the whole thing in Taco Bell style if I'd only manned up and broken out said, but I wussed out and wrote some Python. So um, you know, I think that some of that is tongue in cheek, and some of it is sort of sarcastic in terms of what he's saying there. Now, on the whole, as I mentioned earlier, I do believe the thrust of it, or the core of it, still holds up today, and I think it's one of those things that it will always hold up. The idea, I mean, if you look at this, this is almost like functional programming, because the idea is that you have these almost like Lego blocks. These are, isolated functions that take a bunch of parameters and they produce a certain output, which you then chain. In this type, you pipe. So you take the output from one execution, and then you send it to as the input for the next one in the chain, and then so forth and so forth and so forth. So in some ways, that is a lot like kind of like functional programming, because these tools or these functions, if you treat them as functions, they are deterministic. And the main thing is the fact that they do. I think it's called the single responsibility principle. In fact, let's have a look at that. The idea single responsibility principle. So the idea behind that is that you have a function, or you have a thing that just does one thing and one thing only. Let's get rid of that ad blocker. So yes, the single responsibility principle, SRP, is a computer programming principle that states a module should be responsible to one and only one actor. The term actor refers to a group consisting of one or more stakeholders or users that requires a change to the module. Robert C. Martin, so that's Uncle Bob. So Uncle Bob, obviously, I don't. There's a lot of things I don't agree with, but in this particular case, I do actually agree with him here, because the idea that whatever in abstraction. If you have these sort of Lego blocks, and essentially they are well defined and they only do one thing, you shouldn't overload them to do a whole load of things, because then it becomes complicated and it becomes difficult to reason about, really. So anyway, so what I was saying, okay. In terms of, I think the key real thing is about not over abstracting, not over engineering, and composability. That's the key right there. Is the idea that you have very well defined small Lego pieces that you recombine and reconfigure. That's essentially what he was saying at the beginning. Every item on the Taco Bell is just different configuration of roughly 8 ingredients. So what the idea is that you have these small small building blocks that you just rejig around to solve whatever problem that you have at hand. And it's because each of these blocks are well defined and they do exactly one thing, and the operation of it is well understood, you'll have a far more robust solution, and you'll have it quickly. Having said that, where I would digress in terms of so far I've obviously agreed with that in principle is scale. So of course he mentioned about, what if you have millions of pages and all this kind of stuff, and obviously he's writing this from the perspective of having everything running in on a single machine. Now a modern single machine can handle a heck of a lot of data, but, and this is the big but where I think it can slowly start breaking down, is when you have a scale, a scale such as, for example, Google and Meta and those big techs or whatnot, at a certain point, they're a single machine. You'll hit the limits of a single machine, and I would say these kind of tools would, the ideal, which is very much working on a single machine, the solution starts hitting a limit, and at that point I think you do have to look at things like MapReduce and other sort of distributed computing and that, or distributed system, and that's entirely different ball game, and entirely different context as well, an entirely different scale. And so perhaps there are different sets of building blocks that can be applied in distributed computing. I'm not entirely sure if there are, and I think like a HPC or in those domains. So I think at that end, at that extreme, I think these kind of things start to break down. But I think it's important to also then say how many of us will actually be in at that scale, if that makes sense. And I think maybe that is maybe the argument here is I don't think most people would, and he's only looking at it from the perspective of most people in the small to medium sized businesses, that they would never be at the extreme, or the amount of processing power that a single machine has can handle most of the jobs or most of the problems that most companies will have would be covered by can be covered by a single machine. It's unlikely, and so all of this would still hold. But anyway, yeah, in general, it's yeah, in on principle, it's absolutely correct. At the where it doesn't hold so much is on larger distributed systems where you do have to have a slightly different approach. But I think that's not what he's. I don't think he's advocating it across for everything. I don't think he's saying it is for everything. But yeah, that's the end of this review. And as I mentioned earlier, this is an article that, although it's very old, it's still a lot of the in terms of principles, a lot of those things still apply to the modern day, which is essentially stop over engineering, stop over abstracting, use simple tools, but make sure those tools are composable, that you can, like Lego, you can rejig and reconfigure to try and solve your problems. That should be your first. That should be your when you reach out to build a solution. You should try that first before, if that fails, if that doesn't work for you, then you should then look to actually build your own solution. So I think that hasn't been mentioned, and I think he probably I think that would be my main criticism there, is that, so in principle he's correct. Always reach for the composable tools, if you like, the simpler approach first, and see if that can cover your requirements and your need, and if that can solve your problem. If it cannot, then bust out the big guns, which is actually start building a full-blown solution in whatever particular language that you need. I think, yeah, so that's the only main criticism from me. Anyway, until next time, I'll see you on the next one.